Good morning, Miss Lee and classmates. We are here to present our POU to you. The problem we are tackling is how to be more environmentally friendly by designing the container of drink to minimize the material. Firstly, the material we suggest to be used as the container is aluminium, as it can be thin and durable, reducing the amount of aluminium used to make the container. Aluminium is also recyclable, making it a greener option.
Next, we need to find the best shape that it gives the can the smallest surface area to volume ratio. This allows the can to have a smaller surface area for the same volume. Before we continue, here is the list of terms we will be using. First, let us take a look at a sphere, taking the volume to be a constant 250 ml. We then use the formula for volume to find the radius and calculated the surface area using the surface area formula. We then found that the surface area to volume ratio is 0.768. Next, we considered cuboids. By taking volume as a constant, we found the surface area in terms of its length and volume. Then, we differentiated the surface area with respect to the length. We then considered the stationary point and found that the cuboid is a cube at the minimum points. The stationary point is the minimum as the second derivative always gives a positive result, as seen here. Now, by taking volume to be 250 ml, we found the surface area of the cube and found that the surface area to volume ratio is 0.952.
Lastly, we considered cylinders. We found the radius and height that gives the real surface area. We took volume to be a constant and found the surface area in terms of the volume and radius. We then differentiated the surface area with respect to the radius and found that when at the stationary point, the height is equal to 2 radii. This gives a minimum surface area as the second derivative is always positive. Now, taking the volume to be 250 ml, we found the surface area to volume ratio to be 0.879. Comparing the three shapes, we found that the sphere gives the lower surface area to volume ratio, followed by the cylinder and then the cuboid. However, comparing the sphere and the cuboid, through further research, we found that the packaging efficiency for spheres is about 74% of the packaging volume, but the packaging efficiency for cylinders is 31%. This means that in the long run, cylinders actually save more material, especially for the packaging.
Thus, cylinders are the best shape for drinking, as they can have a relatively low surface area to volume ratio, while having a relatively high packaging efficiency.
Thank you.
Thank you.
Thank you.